Hello and welcome to this SimLogic webinar. Today's webinar is on OEE reporting and your host for the day is Paola from SimLogic, who's our quality manager. I'm Emma Simpson and I'll be the facilitator for the day. So as we go forward, just a few housekeeping rules. If you have any questions throughout the webinar, if you complete the panel on the right hand side of your screen and submit them, at the end of the webinar I will contact everyone who has posted a question with the answers. We are recording this session, so we'll also be sending out details of where the recording can be found to everyone who's attended today. If you think of any questions afterwards or you require any further information, please send an email to inquiries@simlogic.co.uk. So a little bit about our host today, Paola. He's our quality manager and he's responsible for quality assurance, continuous improvement and team development. He joined us in 2014 and he's got extensive project management experience implementing improvement solutions in the manufacturing and utilities domain, including MOM and MES. So without further ado, I'll just hand you over to Paola. Thank you.
Hello, welcome to this webinar. Today's agenda will include a brief introduction to OEE as a continuous improvement methodology, not only as a KPI. We will talk a little bit about how does a performance management system works, basically to how do we collect data automatically and what is the importance of that. And finally, we'll have a demo based on Traxxas version 10 on how can we analyze data on a performance management system. So basically, today, one of the major challenges that manufacturing companies face is how to maximize productivity and utilization with a direct impact on the bottom line. And also having in mind that we have constraints on the manufacturing environment. We have equipment, we have materials, and we have labor constraints. So from our point of view, the only way to really improve is to adopt a continuous improvement process. And for that, we believe that if we collect data potentially automatically, it will be beneficial if we can collect that data in an automatic way and provide context for that information. We will be able to analyze that information with the right context and then afterwards implement improvement actions to adjust processes, skills, and the equipment itself. So it's important to note here that it's not just about technology, it's not just about the equipment that might have problems. Sometimes the problem is on the skill set of the operator, sometimes it's about the processes, and the insight that these analyses will provide will help us actually to drive maximizing productivity and utilization. So OEE, it's a methodology that it's proven in its spread worldwide regarding measuring the effectiveness, the productivity of manufacturing lines, manufacturing equipments. And initially it was associated with the TPM, but more than just a metric. And it's a metric that combines the three big factors that might contribute to the efficiency of a line, availability, that measure downtime losses, performance that measure speed losses, and quality that measure defect losses. Much more than just a KPI. Actually, it can be used on the previous improvement, continuous improvement process that I've shown. So if we look at whole available time that we might have on a production line, some of the time won't be planned, so it's a planned shutdown, it's non-scheduled time, and that time won't be considered for OEE calculation. We will only start from the planned production time. And on that production time we might have losses due to availability, losses due to performance, and losses due to quality. And actually, if we have the ratio between the operating time on the chart by the planned production time, we will have the availability component. If we have the ratio between the net operating time on the chart by the operating time, we will have the performance component. And finally, if we have the ratio between productive time and net operating time, we'll have the quality component. And in more detail, actually availability can be calculated directly from the ratio, as I mentioned, of the operating time by the planned production time, but actually usually performance is measured in another way. We just have the ratio between the parts, the actual total parts produced, by the theoretical parts that should be produced on the operating time. For this, we should have in mind that we should have a parameter to consider the ideal speed of the line. But this might change with different products. So the solution behind should take that in account and should be flexible enough to adapt the speed regarding the line speed, but also the line speed for the different products that may run on that line. And finally, quality, usually instead of calculating times, we use the total good parts produced divided by the parts produced in that period. So considering this and multiplying these three factors, actually we will have our OEE. Besides or decomposing those three factors, the downtime losses, the speed losses, and the quality losses, actually we have three big types of losses on a manufacturing environment. We might have losses due to breakdowns or setup and adjustments, and those will contribute to downtime losses. We might have losses due to small stops or also by running at reduced speed, and those will contribute to the speed losses. And finally, we might have rejects on the beginning of a new product, startup rejects, or production rejects during the normal production time, and these last two will contribute to the quality losses. So theoretically, we have defined how is OEE calculated. I've mentioned a few notes regarding some practical aspects of it, namely the product changes and all that. But usually, a performance management system, an automated performance management system, is composed of 4 different functional layers, I would say. First of all, we have a layer that is responsible to collect data automatically. To have reliable data, it's important to have automatic data collection, at least to detect the actual production counts and the actual downtime durations. For that, sometimes we might have a simple system just collecting a few signals, or we might have a more comprehensive system that can also collect data regarding context. Particularly, we may be able to collect what is the product running on the line, or what is the shift that it's currently in production, or eventually interfacing other systems to give more context to the information that it's collected automatically. So this is the goal of the automatic data collection layer. Usually, I would say that it collects machine status and production counters. All this data is collected and stored in a real-time production database, and that real-time production database will serve the operation interface. The operation interface usually stands by the line, can be a mobile or a fixed workstation, where the operator can interact with the system. And in these workstations or these mobile stations, the operator can tell additional context information about the job that it's running, the production order, the product that it's running, can assign downtime reasons. So complementing the information that it's gathered automatically, it can assign typified reasons why did the system stop, or can complement that information with notes. Usually that is the goal of that operation interface. And we have on top of it an analysis layer, functional layer. Here is where we can analyze all the information. We will have dashboards to perform reporting over the information that was gathered in the production database, and this will be the focus of today's webinar. I will also mention the fourth component, which is the administration, where we usually may edit data, reassign reasons, for instance, or adjust parameters that we have on the system, like the theoretical rates for the products. But today, as I mentioned, we will be focused on the analysis. And for the analysis, we might have different approaches. We might, for instance, analyze a specific case, a specific incident that we might have. For instance, let's say we had a big breakdown and we want to understand why and in what circumstances did it happen. We can go directly to that period and understand what happened. But usually when we try to improve, we use a top-down approach. So basically we try to focus on the component with higher impact on the performance losses, performance or quality or availability losses. We try to understand what is that component, and then we'll drill down, like in this example. We might find that our OEE is too low, and its biggest contributor, its biggest reason, its biggest factor was availability. Then we can drill down within availability and find out that, for instance, the biggest contributor were the setups and adjustments that were too high. And by drilling down and by analyzing the context of this information, we can actually investigate what was the root cause for that, and then address that problem. And then we can go again to that continuous improvement process that I've mentioned, and somehow action that, and then measure again, and then continuously improve and address other issues that we might have. So first of all, we try to focus on the components with higher impact, and then solving that problem, we can move to the next one and in a continuous improvement cycle. At this point, I might also would like to tell that having this top-down approach in mind, we can also understand that sometimes the investment, the cost, the effort to collect data should be also balanced. It's not suitable to try to collect all possible data because it might not have an impact on maximizing productivity, might not be a reason for the downtimes, might not be a reason for the performance losses. It's better to start simple, start collecting the data that is available, try to provide context, try to understand why, and then we can focus on that specific area and dig down and gather more data if we need. Telling this, I would like to go to the demo and show you how to put in practice this approach. So right here we have an example of a dashboard. This is a global dashboard for a production line. It's a demo production line where we can see for a certain period. We are currently looking at a specific month of data. We can see that we have an OEE quite low on around 37%. That the biggest contributors would be the availability. Availability in this case is too low, 46%. We have a performance of 82% and a quality component of 97%. If we look on the right-hand side, top right-hand side, we have a pie chart with the split of the time. We can clearly see that 1/3 of the time the plant was shut down, so we were working basically on 2 shifts. And on the 2 shifts, the biggest component is the breakdown. We can actually see that the breakdown during these months was about 200 hours. This means a lot of losses due to breakdowns. The impact is huge during these months. We can drill down and try to understand it better in the next few minutes. But this is the first, in the first approach, that's what this chart tells us. But if you look down, actually we have a Pareto chart that will list the top 5 reasons, and actually more than the non-scheduled time, the breakdowns really impacted the production during these months. We'll try to understand why in the next dashboard. Let's go to OEE overview and have a detailed view along the timeline of how did the OEE perform during these months. So we can see that we have a lot of ups and downs throughout the month. We have dates where we didn't work at all, where we have 0% OEE, but we can clearly see that there were some days that were particularly low. We can start by investigating some of those cases. Let's look at the 17th, where we have 17%. We can actually drill down. Let's try to see what happened on that date. Yes, it was really low, and we have seen that availability was quite low on that day. We can drill down into availability and see what happened exactly on that day. On the availability, okay, we had a problem, big problem with the wrapper that was not running. We can try to see hour by hour what happened on that day, and we can analyze on the timeline chart some ups and downs, and really 2 periods where it was quite low. Actually, I believe that we might have some downtime events, and for that to have a good perception of what happened during that day, let's try to drill down and understand, grouping by category, which are the downtime reasons, try to see what happened during that day. Okay, we have for that day a Pareto chart that can show us clearly that we have here some issues. If we look at the top, Pareto chart is a duration Pareto chart, and on the bottom we have a count that gives us the frequency of the different events. We have here, if you look at up, we have about 650 minutes lost due to sanitize and product change. This is quite a lot. We are talking about 10 hours of losses during that day, and it's strange because we have a changeover. Usually they take time. I'm not sure if this one took more time than expected or not, and this is something that you can drill down, and if you know your process you can always benchmark the time lost. But we also have here some cleaning. Let's try to see shift by shift what happened. So early shift, let's filter by shift and see what happened here. Here we don't have any sanitation and any product change, so it might have happened on another shift. Let's see the following shift, back shift, the afternoon shift. Let's see what happened in this shift. Okay, so we have here the product change. So the product change happened during this period, and if we click on that event, on that bar, product change, actually we have here the detail. It was a changeover that happened from 4:34 till 22. So it's 5 hours and a half for a product change on that line. That seems a lot to me. But anyway, the shift ended up and he left with a new product for the next shift. Let's see what happened in the following shift, on the night shift. Actually, there we are. There we have the cleaning. So basically we spent 5 hours changing product, and afterwards 2 hours after changing product at midnight, the next shift had to perform a cleaning. So someone went wrong on that product change. It took a lot of time, and actually we had to clean it afterwards and have to prepare it for a new product. And this brought 10 hours more than a shift of loss during that day. And that's what caused such a big downtime on that particular date. But I've noticed something. When we were looking at whole shifts, let me get back to the filter with all shifts. I noticed that it's not the biggest contributor in duration. Actually, it's the fifth, but the short stops are the most frequent reason. And actually, we had 89 forced stops during a day, with a total duration of 71. So more than 1 hour was due to short stops. These short stops, the way we were measuring this line, we were measuring the in-feed, and actually the in-feed of the filler, when it detects no flow, it will tell us that there is a stop. And if the stop is under 1 minute, it will record a short stop. And if we have all this time, eventually we might find that if we had a buffer on the filler, we might be using the filler at maximum capacity, and we could have an hour extra of uptime for this line. So these are the type of conclusions that we might take from the downtime analysis of a line. We were looking at a particular date, the 17th. Also the 17th, we found that we have a major downtime during due to a problematic product change that afterwards demanded a cleaning, and we found also problems with short stops. Let's go back to the top again, and let's try. Before, let's take a brief look on where we were finding that the performance was also low. Actually, the performance had quite inherent behavior, and that might be also a problem, and that's another type of analysis that we can also do regarding performance. And also we had for that day, before moving further, we also have a problem with quality. We can also drill down on quality and try to see what were the reasons for these quality losses, and we can also understand if it was due to a certain product on that day. We can filter that data. No, it was not for a specific product. We can also analyze along a timeline, hour by hour, what was the behavior. Actually, it was quite low, but didn't change much. The biggest contributor was the sealing. We have more than 1,000 units rejected by sealing, some by quantity, some by label, but that's actually another type of analysis that we can perform. So we can drill down. We will be able to drill down in quality, in availability, and performance, and see where did we had our problems. Let's get back to our monthly view. I'll filter it again regarding the full months, and let's try to investigate another case. Okay, we have here our monthly view. Let me try to, instead of, we can select different types of filters, different types of grouping. In this case, we are looking at hour by hour. Let's see day by day, because we are talking about a month. If we look carefully, besides the 17th, there is also quite a low value on the 22nd. Let's try to find out what happened on the 22nd and see if there is another different reason for that. And of course, after analyzing all these, we will need to arrange, to agree within the team what should be the appropriate improvement actions. Might be a process. We are talking about, previously we were talking about a changeover. Let's see what happened on this particular day. Let's look again on the events that have composed these. Let's see a Pareto of the different reasons. And here we have a big loss due to a breakdown. We have a jam in a sorter that took us 360 minutes, 6 hours, 6 hours with a problem in the jammer. Seems also a lot. And actually, as before, we can try to understand what happened, what shift did it happen. And actually, with these filters on the shifts, we can benchmark different shifts and see how did they behave. So there was no problem on the early shift. Let's check the back shift. Interesting. We have here 159 minutes for the filler and 91 palletizer. Actually, let me see the last shift, but I wonder if there isn't a connection here. So jam in sorter, we don't have many, we only have, if you see look at the frequency, we only have one stop for the jam, for the sorter due to a jam, but it took these 6 hours. Let's look at the detail of this event. Actually, it started at midnight. Again, another event at midnight till 6 a.m. So almost full shift was stopped trying to solve the problem of the jam. Potentially in the evening, in the night shift, they didn't have the right people to support them on maintenance. Not sure, but something that I also noticed is that on the previous shift, we also have here a problem on the palletizer. Let's analyze what was that problem on the palletizer. And actually, let me see, we had several stops on the palletizer, and some of them, latest one was at 9 with an infeed jam. I wonder if that might have caused, because in this case the machine is right before the palletizer. So eventually a problem that was not properly solved in the previous shift might have caused that. But again, this depends on the process, depends on the production model that you might have. But as you have seen, we can analyze and dig down different reasons that might have caused a lower performance on what we are looking at. A typical performance management system like this one designed on Traxys, will allow you to drill down on all these potential reasons and understand why are we producing below our expectations. Also interesting, the color code in this application can also help the operators to take as much value as possible from the tool from a visual point of view. The red means that we are clearly under our baseline. That means under what is as an average we can achieve with this production line. On blue if we are between the baseline and our target values, and above green on target. So blue means that we are on the right track, but we need to improve. Green, we are above our target, and red, clearly we are under our target. Let me go back again to see another date, and let's not just think about bad cases. Let's end with a good date, with a good day of production, and see what happens in a good day. So you see here, as I mentioned on the tiles, they are blue because we are above our baseline. We are on the right track. Regarding quality, we are not producing so well as we would expect. We still have some problems. Okay, just before going to a good day, let's just do one exercise and try to understand what happened due to quality, because I'm finding out odd that during a whole month we are so low on quality. Actually, we had a lot of rejects. We had 40,000 bad units in a month. That's quite bad. Let's try to find out if this is somehow related with the product. Let's see one of the products. Okay, approximately half of the rejection. Let's see this other product. So it's interesting to notice that we don't have any rejects regarding sealing. This might tell us that we might have a problem with the sealing on a particular product. That might tell us that the supplier for the sealing for that particular problem might have some defects. We might need to analyze what's that product or what's that process of sealing, and understand why some products are affected by that and some are not affected at all. Might be a problem on the supplier. Again, as I said before, it's more than just the actual automatic captured data. It's important to have context. The more context you have to analyze the information, the more value you will have, and the easiest it will be for you to understand the root cause and then address those problems. As I promised, let's go and find a good case to hand, and let's go on the timeline. I'm just looking at the shift. Let's try to find row shifts and clean all filters. Okay, let's look at our record. Let's put here our record, 73%. Let's take a look at the 14th. 14th was the best day in the month. We should be able to find some good examples on what should be done on the other days. Yes, clearly we are on the green. We are above target. Good availability, good performance. Quality was inconsistent, but as we have noticed before, might have the impact of a supplier product that was incorporated, the raw material that was incorporated, or a process. Let's look on the events that we have on that day, on the on-time events, and see what can we learn about it. Let's see on categories. We might filter for different by different dimensions. Let's look at this case for category, which will be one of the most used filters. So actually we were okay. We were on green. Availability was above target, but anyhow, if you notice, we still had 125 stops, short stops. Still, we have more than 1 hour and a half almost of short stops. If we could really somehow address this, tackle this problem, actually we could improve even further. So even in good days, we might learn something, and it will be beneficial if we could use these dashboards, the overview maybe, to discuss with each shift when they start, what happened in the previous shifts, what were the good practices, what were the problems that they faced, and then try to improve every day. That's for me. That's all for me. Thank you very much. Please, if you have any questions, don't hesitate to send us your questions. Thank you.
Thank you very much, Paola. I'm sure you'll all agree that was very informative. If you do have any questions, if you'd like to email them to inquiries@simlogic.co.uk. Any questions that have been submitted throughout the webinar, I will be responding to via email. And as I mentioned in the introduction, the webinar has been recorded and will be sent out to everyone that registered. So all that's left to say is thank you very much for joining us, and goodbye.